Okay. To start with today, we're going to look at scatter plots. And scatter plots are something that you have dealt with in the past. Um, some things to think about on scatter plots is they do not involve graphing lines. We will talk about what we'll do with lines here in a minute. But as far as a scatter plot is concerned, you're just looking at a graph of a lot of points. There are some things that we talk about when we deal with scatter plots. I'm going to just sketch a few scatter plots up here. Just examples of. These are all in quadrant 1. So we're not dealing with any negatives, x or y values at the moment. But there's an example of one kind of scatter plot. Another one may look something like this. So that could be another one. And another one might look like that there. And another option may look like this one. Okay. So one of the things that we discuss when we talk about scatter plot is how close together the data is. And the word that we deal with when we talk about how close together the data is the word correlation. That's asking, does the value of the x matter to the value of the y? Is there a direct correlation? Is there something that makes one go up while the other one goes up, or one go down while the other one goes, or one go up while the other one goes down? Either one of those two things. And so if we look at the types of correlation we have 3 types. One is positive, one is negative, and the other is there is no correlation. So there's 3 options. On the graphs that you have on the board right now, this first one, since as the data goes to the right, the data is also going up, that's positive correlation. As one increases, the other increases. Okay. On this, we'll call this graph plot 1. Plot 2. Notice how it just kind of goes up and down. There's not really a kind of a good pattern. It just kind of goes up and down. And so on this one, we're not really having a correlation at all. Okay. On plot 3, again, as the data goes to the right, the data is also going up. So number 3 is also a positive correlation. And then on number 4, as the data goes to the right, the data is going down. And so this is a negative correlation. Okay, so those are some different types of correlation. You have positive. We have 2 examples of that. You have one of no correlation and one of negative correlation. So these are things you're going to need to be able to recognize. If the data, like on number 1 and number 3, if the points, the plots, the dots are moving up to the right, then it's positive. If like on number 4 down here, if the data is moving down to the right, then it's a negative correlation. And again, if it's all over the place like on number 2, there is no correlation. All right. So a couple of things. That's going to be part of your assignment for tomorrow. You're going to be able to tell me, does the data go up? Is it positive? Does it go down? Is it negative? Is there no correlation? And so that's going to be about half of your assignment tomorrow. Is going to be you just telling me that. Okay. Another piece of this, though, is the difference between number 1 and number 3. Okay. If you look at those closely, there's a little bit of a difference. Okay. On number 1, you kind of have this correlation that kind of, the data almost goes in a straight line. Okay. And this kind of correlation we call linear. So we have positive linear correlation on number 1. If you look at number 4, this one kind of goes in a straight line direction. There's that one kind of weird piece of data out there, but for the most part, it's that straight line. So it's also going to be linear. So on number 4, it's actually negative linear correlation. But on number 3, there's a little bit more of an issue because it's not really a straight line. What you end up with is something that looks like this. And so since we're dealing with linear, this one would be nonlinear. Okay, so the data is not in a straight line, okay, or even in the direction of a straight line. It has a curve to it. So like I said, about half of your assignment tomorrow is you going to be telling me, you will tell me what kind of correlation. Is there a correlation? If there is it positive or negative? And is it linear or nonlinear? Okay, and so that's the biggest chunk of the stuff for tomorrow is that. Now, the harder stuff, though, deals with actually graphing the data, making a scatter plot. Okay. Now, I'm going to pause for just a second because I don't want the bell to catch us. So give me just a minute and I'll come right back. Okay, so to continue with this, we now have some data, some x and y values that we're going to plot on a scatter plot. So your data here, your directions here would be make a scatter plot of this data. So let me write that up here. Okay, and so what we have to make the decision on here is what are we going to have across the bottom, okay, and then what's going to go up the side. So it's easy to say what's going to go across the bottom is your x values, and what's going to go up the side is your y values. But how are we going to split those up on the line? So how are we going to label them? What are we going to do for our units? We're going to skip by ones, tens, hundreds. What are we going to skip by on the bottom? Well, since on the x column we're only going from 1 to 8, first off, always start at 0 if you can. In this case, that's very easy to do. But for the x's, we can just count by ones. So the first line will be a 1, then a 2, a 3, a 4, a 5, a 6, a 7, an 8, and I'm going to keep on going for a couple more of those just to round out the labeling. But it gives you plenty of space there, 0 to 8. Okay. On the y's, though, there's a little bit different thought process. Throughout the day, the answers I've heard first off were, hey, count by hundreds because we got to go up to 300. So if we count by 100, that's leaving way too much space up here at the top. All of this space would be kind of wasted. So instead of doing by hundreds, let's go for something a little bit smaller. Still starting at 0. Okay. Let's do half of that. 50, 100, 150, 200, 250, 300. Again, we still have quite a bit more lines here. And to be honest, we have the same number of lines left that we started with, or that we've already used. So instead of going by 50s, we're going to drop even further down. And we'll do half of that. And we'll count by 25s and see if how that works. So start here on the first line is a 25, because again, the first line itself is 0. Then you got 50, 75, 100, 125, 150, 175, 200, 225, 250, 275, and 300. So that gets all of our values from 0 to 300, which covers what we're needing for the y. So you want to make your lines, they all need to be the same distance. Notice I went from this spot, from here to here is 25 units. From here to here is 25 units. Every space is 25 units going up the side. Across the bottom, every space is 1 unit. And so I don't want to do like from 0 to 60 and then do the next line is 120 and the next line is 150, because then where does 80 go? And so you gotta make some sense of that. It needs to look like You know what you're talking about on there. All right, so let's plot some points. The first one, the x is a 1, and the y is at 60. So on the graph, I'm going to go over to the 1 on the bottom, and I'm going to go up to 60. And 60 is not quite halfway between 50 and 75. It's actually closer to 50. So I'm not going to put it in the exact spot, but that's pretty much where it goes, right there in that red dot. Okay. The next one is 2 and 120. So I'm going to go over to 2 on the bottom, and I'm going to go up to almost the 125 line and put a dot there. The next one is 3 and 150. This one's nice because it's both on a line. I go over to the 3, and I go up to the 150 and put that dot. Then also on 3, I'm going to go up to only 80, so that's right above the 75 one. And then I'm also going to go from 3 to 175, so there's another dot there. Okay. On the number 4, so going over to 4, I go up to 210. So somewhere in that neighborhood right there. On 5, I have both 200 and 220. So where 5 is, I go up to 200, and then also 220. And then on 8, I go up to 300. That's that top line. Okay, so there's my scatter plot for that data. So just from what we had a while ago, how could I describe this scatter plot? Well, there's definitely positive correlation because it is moving up to the right. Okay, as I move to the right on the graph, the dots are moving up for the most part. And then it's also linear. I mean, it's not perfectly linear, but it's a pretty good spot. Okay, and so that's kind of where we are for the moment. Can you get that back down to where we need it? So somewhere right in that neighborhood. So the first thing it'll ask you to do is to make a scatter plot. But there's another piece that it's going to ask you about also. It's going to ask you to find an equation for the line of best fit. And so here's kind of the way I want to do this line of best fit. I'm going to draw 3 or 4 lines up here, and we're going to talk about which one works the best. So I'm just going to kind of use a couple of the dots that are already on here and draw lines through them. So I have that purple line to start with, that green line next. We'll do this orange line. Okay. So if I had to choose which of those 3 was the line of best fit, notice this purple one for sure is out. It's not even an almost. It only touches 2 of the dots, and then every other dot is way away from it. Okay? The other one I want to knock off really quickly is the green one, because it touches 3 of the dots, which is really good for your data purposes. But every other dot on here, this one, this one, this one, this one, and this one are all on kind of the underneath side of that green line. And so that green line is not really a good gist either, a good representation. And so with the orange one, it goes through these 2 and even touches this one out here. And it's got these 3 dots above it, and then this dot, and this dot, and this dot kind of below it. So that's a pretty good representation. Again, it may not be the exact line of best fit. Eventually this year we will use our calculators to figure that out. But it's a pretty good little location. So, directions on this part is draw a line of best fit and write an equation for it. All right. Now, so we're going to use this orange line. And so one of the reasons why I always, on all 3 of my lines, I drew it through at least 2 of the points is because if I'm going to write an equation, I need to have it go through 2 points that I know so that I can find the slope. Because to write an equation, I have to have the slope. And so if I'm using the orange line, this point right here is a pretty good one. So that point there. And then let's go out here to this end one, and we'll use this one at the very top. And so those are two points. And I can use my table of values over here to figure out those. This point right here is at x is 2 and y is 120. So if I look at my table of values, so my first point I'm going to put is a 2 and 120. My second point up here at the very top, we know is at 8, and so the only one at that spot is 8 and 300. So my second point is going to be 8 and 300. So from our time together last week, if you were given 2 points and you were told to write an equation, the first thing you got to do is find the slope. So slope formula. Y2 minus Y1 over X2 minus X1. Okay. And then once you have the slope, then we can write the equation. So I'm going to label my points up here. We'll just label the first one as X1, Y1, and the second one is X2, Y2. And it does not matter which one you label with the ones and which one you label with the twos, as long as you put the ones together in the parentheses. The X1 and the Y1 have to stay together. The X2 and the Y2 have to stay together. So now I'm going to put this in my formula here. We have 300 minus 120 over 8 minus 2. So 300 minus 120 is 180. 8 minus 2 is 6. And if I divide that, 180 divided by 6 is 30. So my slope, my m, is 30. Okay. Now, my form that I know now to use, if I know my slope and I know a point, then I'm going to use point slope form. And point slope form is y minus y1 equals m times x minus x1. And I can plug in the information I know from this problem. So if I use my same x1 and y1 from the problem, I will now have y minus y1 is 120 equals m, which is 30, parentheses x minus x1, which is 2. So that's my equation in point slope form. The assignment tomorrow is going to ask you to put it into slope intercept form. So to do that, all you need to do is solve for y. And so the first thing, we did this about a week and a half ago maybe, is distribute to get rid of those parentheses. I do 30 times x is 30x, then 30 times the minus 2 is a minus 60. Okay. And then we're almost done because the y, the only thing left with it is that minus 120. So to get rid of the minus 120, I have to add 120. So that cancels out, and I'm left with y on the left. And then I add 120 over here to the minus 60. So we end up with y equals 30x, and minus 60 plus 120 is a positive 60. And so this is my equation in slope-intercept form for the line of best fit that I chose for that data. Okay. All right, I hope you don't have any questions. Couple of reminders. One, Monday, submit bell ringer and echo. Submit a new post on Jobs Part 3 with the 10 questions. These are 2 things that are due today, Monday. Okay. Tuesday. Complete the scatter plot worksheet and turn into sub. Get you through the first half of this week for sure. Wednesday, work on Jobs Part 3 final submission. So if you haven't, you need to have your interview completed. In other words, talk to whoever you're talking to before Wednesday. So that you can write this up on Wednesday, because that's what you're going to have class time Wednesday to work on this. So you can get all the writing it up on Wednesday. Okay? And then your Jobs Part 3 interview is due when you walk in the door on Thursday. Okay, so that'll be the next time that we do some new material. We'll talk about standard form of an equation on Thursday. Let's see, that's when your next assignment will be. Okay, so y'all have a good week, and I will see you when I get back. If you have questions, you can email me. I will not be near my computer most of the day, so I may not be able to get back to you during the day, but I will send back responses in the evenings or the morning.